Hello again. Welcome to another lesson in geometry. Today we're covering Chapter 1, Section 4, Measuring Angles. All right, so your warm-up, use the diagram at the right to answer questions 1 through 4. And so this diagram has two line segments that bisect each other. Remember, bisect means they split in half, and that's what these little marks here and here, these AD and DC are the same length, and ED and DB are the same length. So we're going to use that information to help us answer these questions. All right, so this first question says if AD is 20 and AC is equal to 3x plus 4, find the value of x. Then find what AC and DC are. All right, so I know from this picture that AD plus DC should equal AC. That's the segment addition postulate. The two small ones should add up to the big one. And I also know that it's bisected so that this small one and this small one should be the same. So if AD is 20, then DC is also 20. And then we know the formula for what AC is. It's 3x plus 4. Okay? So 20 plus 20 is 40 equals 3x plus 4. Subtract 4 to both sides makes 36 is equal to 3x, and that means x is 12. So there's one of our answers, x is 12. And now we need to find out what the value of AC is and what DC is. So AC is going to be equal to, and I'm going to show this algebraically, 3 times 12 plus 4. So that's 3 times 12 for 36 plus 4 for 40. Okay? And then we know that DC already should be 20 because it bisected. So there's our three answers. Now, if they didn't ask you to find x, and they just said, hey, find AC and DC, you should be able to do that without any algebraic stuff. So if you think about it for a second, oh, well, AC is going to be twice of AD, so 40. And DC would be exactly to AD, so 20. And that's because of this bisector. If this was 20, this one had to be 20, and then the whole thing had to be 40. All right, number 2. If ED is equal to 5y plus 6, and DB is equal to y plus 30, find the value of y and then find all the little segments. So ED is one of the small ones, and DB is one of the small ones. We have different formulas for those, but we know that they should be equal to each other. So I know that ED should be the same value as DB because AC bisected EB in half. So cut it right in half so that these should be equal. So we're going to put 5y plus 6 where ED is. We're going to put y plus 30 where DB was. Subtract y to both sides. This will give us 4y plus 6 equals 30. And then subtract 6 to both sides. So 4y would be 24. And that means the value of y is 6. That's one of the answers we were asked to find. ED, okay, well, that means I got to plug 6 back in here. So 5 times 6 plus 6, that's 30 plus 6 for 36. DB, I'm going to plug it in just to check myself algebraically that I did it right. So 6 plus 30 for 36. This is good. They're supposed to be the same. And that means that EB, the big one, should be those two added together, which makes 72. So there's all three answers. All right, number 3. DC is equal to 6x. And DA is equal to 4x plus 18. So we know that DC and DA should be equal to each other because they have the double marks on it to show that. And that meant that EB bisected AC in half. And let's see, we have two formulas here. The first formula is 6x. Our second formula is 4x plus 18. And then we solve for x, so subtract 4x to both sides gives me 2x equals 18, and then divide by 2 to get 9. It says find the value of x, so there's one of our answers. And then find AD, DC, and AC. So DC, let's see that one first. That's 6 times 9 for 54. DA, which is AD, we got 4 times 9 plus 18. 4 times 9 is 36, and 36 and 18 makes 54 again. Okay, and then we know that the whole thing should be DC and AD added together, so 54 plus 54 makes 108. Number 4, if EB is equal to 4y minus 12, let's take a look at our picture again. So EB is the whole segment, and ED is y plus 17. Find the value of y. So we know the whole length, and we know one of the short ones. So we know this, ED plus DB should equal to EB. That's our segment addition postulate. The two short ones add up to the long one. All right, so, and we also know it was bisected. So ED and DB should be the same length. So if one's y plus 17, the other is also y plus 17. And then EB is 4y minus 12. All right, so we'll put the y's and the 17s together on the left side. So that's 2y plus 34 equals 4y minus 12. Subtract 2y to both sides. 34 equals 2y minus 12. Add 12 to both sides, so 46 equals 2y, and then divide by 2 for 23. Now let's plug that back in and make sure it makes sense. So we have ED. ED is going to be 23 plus 17 for a total of 40. Okay. I'm going to try EB, and hopefully that should be 80, and then I know I did it right. So let's see. 4 times 23 minus 12. So 4 times 23 is 92, minus 12 makes 80. So I know I did that good. And then I know that, let's see, what was our last one? DB. DB should be the same length as ED, so I'm just going to write 40. All right, let's see what new stuff we have for today on the second page. All right, on the top of the second page here, we have a new definition, angle. An angle is formed by two rays that share a common endpoint. So last time we learned what a ray was, it was kind of like half of a line. We have an endpoint, and then the line goes on forever on the other side. So provided that two rays are non-collinear. So the non-collinear means that they can't be together. So you can't have the ray like this, and then the second ray right on top of it. Okay. All right. So the common endpoint of the two rays is called the vertex. So here's our vertex. Okay. And the two rays are called the sides of the angle. So in red here, we have the sides. Okay. You can name the angle below angle ABC, angle CBA, angle B, or angle 1. So 4 possible names. Notice we pick a point from the side of one of the angles. We go to the vertex in the middle and then the other side, and then this reverses it. But if we use 3 points, the middle point should always be the vertex. If we use only 1 point to name the angle, then it needs to be the vertex point. And we can also name it with the interior number, so in this case a 1. When naming an angle, use 3 points, so the vertex is always in the middle. The interior of the angle is the region containing all the points between the two sides of the angle. So in here, this is the interior, okay? And the exterior is out here. Now, the angle itself is neither interior or exterior, so that this part in green, these points are not on the interior or the exterior. Okay. All right, let's take a couple questions here. What are 2 other names for angle 1? So one of them could be angle JMK, and the other could be angle KMJ. Notice the M is in the middle both times. I could not call this angle 1 or angle M though, because which one would I be talking about if I called it angle M? Would I be talking about angle 1 or angle 2? Or maybe the combination of angle 1 and 2, which is angle JML, okay? So what are 2 other ways to name angle LMK? We could name it by its interior number, so angle 2, and we could name it angle KML, okay? Once again, you cannot name it angle M. So why is JKM not a correct way to name angle 1? JKM, let's see. This is not the vertex. And the vertex always needs to be in the middle when you name it. So angle JKM is actually talking about this angle? Okay. Which point is in the exterior of angle 1? Okay. So J, M, and K are all on angle 1, so they're not in the interior or exterior. That only leaves point L, and he is in the exterior. So point L. Okay. Would it be correct to name any of the angles angle M? And this would be no, and we've already explained that. If you use only the vertex, there must be no confusion. And a better word for that is ambiguity. Ambiguity here means you can't confuse which one it is. So if I say angle M, I must only be able to tell which one is M. In this case, we can't tell which is M because it could have been angle 1, angle 2, or angle JML. Okay. All right, how to measure an angle. I really suggest you buy your own protractor, but I'll loan you one in class. Okay. So the measure of an angle is the smallest amount of rotation about the vertex from one ray to the other, measured in degrees. According to the definition, the measure of angle should always be any value between 0 and 180. Okay, so we actually have a name for when it's exactly 180. It's called a line, but we could also call it a straight angle. But an angle has to be bigger than 0 and less than 180. So the geometry tool we used is a protractor. I really suggest you go and buy a protractor along with a compass. Okay, but if not, I'll loan them to you. Place the center mark of the protractor at the vertex. So this is my angle in this case. I'll draw it in red. We set the center here. Okay. All protractors have a little bit different. So most protractors, though, do have extra stuff below the vertex, so that extra line down there. And usually there's a ruler there to go with it. You line up one side of the angle with the 0 mark, and then you read the measure on the protractor. Now this is where we get a little confused. So this is my 0 here. So when I read this, this is actually a 50-degree angle. Some people just go, oh, that number says 130 there. I'll call it 130. So just use your brain a second and think, okay, you all know what a right angle is. That's the 90-degree angle. So this angle is less than a right angle, so it has to be the 50 is what I should be reading. Okay. All right. So what is the measure of this angle? It's 50 degrees. And we already talked about starting at 0, okay? Congruent angles, another definition. Two angles are congruent if and only if they have the same measure. You can use identical marks to show that two angles in a figure are congruent. So just like we did with congruent segments, we put little marks on it. Those little marks show that these two angles are the same. So angle dog is congruent to angle cat. Congruent symbol is just like for segments, it's the equal with the squiggle on top. That means the two angles are the same. Okay, if we lay them on top of each other, they match perfectly. And then if we want to talk about the measures of the angles, then we put the equals, because these are values. So the measure of angle dog, which is a number, is equal to the measure of angle cat, which is also a number, some number of degrees. All right, on our last page, we have 4 classifications of angles here. So angles can be classified by their measure. If a measure is less than 90, this is an acute angle, an acute little angle. And if the measure is equal to 90, we know this one. This is a right angle. So this is all the geometry you learned in 6th, 7th, and 8th grade. Angles that have measures greater than 90 are obtuse angles. Okay. And angles that have measure equal to 180 are straight angles. Okay, so acute little angle, obtuse sounds like obese, so that's a fat angle. And then our right angle turns exactly a right corner, and our straight angle is, of course, straight. Okay, we have the angle addition postulate. The angle addition postulate states that if two angles joined, okay, on a side, then the two small angles add up to the big angle, much like what we had for the segment addition postulate. The two small segments add up to the big segment. So in this case, AOB, the blue one, plus BOC, the red one, the other little one, equals the big one, which I'll draw in green, okay, AOC. So the two small ones, the blue and red, add up to the big green, right? So we can use that to solve questions, and we make them algebraic, so it gets a little harder. So the measure of angle RQT is 155. So RQT is our big one, and we know that whole thing is 155. What is the measure of RQS and of TQS? Okay. All right, so I know that RQS plus TQS should equal RQT. And that's the angle addition postulate. The two small ones should add up to the big one. I know the big one's 155. Okay, so we're going to get the other ones. 4x minus 20 plus 3x plus 14. And then we'll solve this. We add this up, we get 7x minus 6 equals 155. We'll add 6 to both sides, so 161. And then we'll divide 161 by 7. And I'm going to pull out the old calculator here. So 161 divided by 7, I get 23. So x's value is 23. So now it asked us, what is the measure of angle RQS? Okay, so that's going to be 4 times 23 minus 20. I get 72. Now, if you are confident in the work that you've done so far, then you could find the measure of TQS without using algebra there, without plugging into your formula, by just doing 155 minus 72. But I'm going to just double check myself because it's always good to do that. So I'm going to do 3 times 23 plus 14, and I get 83. And that makes sense because if I add them up, it makes 155. All right? So what algebraic expression represents the measure of RQT? And we've already found that. We knew that these two added together, these two algebraic expressions added together, made RQT. So when we combined them, we got 7x minus 6. Okay. Classify angle RQS by its degree measure. RQS was 72. So this is an acute angle. Okay. If the measure of DEF is a straight angle, so this is number 9, this is a different one here. So DEF is a straight angle, so I know this is 180 degrees. What are the measures of DEC and CEF? Okay, well that means the two small ones, my angle addition postulate, DEC and CEF, should add up to 180. So this plus 2x plus 10 should equal 180. I'll combine my x's. So 13x minus 2 is 180. Subtract 2 from both sides, so 13x is 178. And then I'll use the calculator again, 178 divided by 13. And let's see, I should have added 2 onto that, so let's try that again. That's 182. And 182 divided by 13 makes 14. That sounds a lot better answer than I got the first time. All right, so x is equal to 14. What are DEC and CEF's measures? All right, so the measure of DEC, that's going to be 11 times 14 minus 12. This gives me 142. Now, if you are confident in all of your other work, I made a mistake in it, so I always double check myself. Then you could just say 180 minus 142 to get CEF. But I'm going to try it anyways. And let's see, so that's 2 times 14 plus 10. This gives me 38. And notice if I add those two numbers together, I get 180, which is good. Okay. All right, is it possible for both DEC and CEF to both be acute angles? This would be no. Well, why not? All right, so together they have to add up to 180. So for one of them to be acute, it has to be smaller than 90, so like maybe 89, okay? That means the other one's already bigger, 91. If it was exactly 90, there would be a right angle. We'd have 2 perfect right angles, okay? So it's not possible for 2 acute angles to add up to 180 because acute means they're both smaller than 90. So 2 numbers smaller than 90 could never add up to 180. All right, I'll see you in class next time. We'll do some practice.